Okay, family, this should be our last video for the quantitative data that we're talking about today, but I'm going to let you in on a little secret. I'm actually filming this before I film histograms. So if you've already watched the histograms, maybe you know why, but histograms are kind of a chore. So I'm doing the two easiest ones first before I dive into the histograms. So what I just filmed was our dot plot. And the nice thing about dot plots is that they are easy to graph and they still let you see the things that you're interested in when you graph data. And we talked about that as being shape, spread, and outliers. Now we need to add in center, but I'm going to say it again, we're going to wait until we can talk about that a little bit more in depth. So dot plot's easy, allows us to see all of the things that we're interested in. Stem plots, I'm on back-to-back stem plot, sorry, I should be on just regular stem plot. Stem plots, I think, are my favorite plot. I love stem plots. I think they're just about as easy as a dot plot, maybe sometimes even easier. Because of how you get to write the data down. So for instance, this data set would not have taken so long with a stem plot. We would not have had to write all these individual tick marks like this. So stem plots, they're fast, they're easy, and they still allow you to see all of the things that you're interested in. So stem plots are also called stem and leaf plots. I'll probably call them stem plots most often. This is the coolest thing about stem plots. So stem plots give us a quick picture of the data. Sorry, I'm just making sure I'm telling you the right thing. Nope. It's a good thing I didn't write that down. Stem plots give us a quick picture of the shape of a distribution while including the actual numerical values. So stem plots got a lot of things going for them. They're easy. They're easy and they're quick to make. You can see the shape very easily, but you also get to see the actual values in your data set. So there are some steps that we need to follow when we make a stem plot. So step number one is we need to write the stems. Step number two, you write each leaf on the proper stem. And then step number three, you order from least to greatest. So actually, I would say that whenever you get a data set, you should just order the data set first. I would order your data set, then decide on your stems, then put your leaves down. So I am rearranging those because I think that that will make this the quickest. And luckily, if you just take a look down here at the data values that I gave you, you can see that they are already listed from least to greatest. So if we were doing this for the Barry Bonds data, the first thing that I would ask you to do is order these data values least to greatest. That would be easier now that we made the dot plot because they're all just there, least to greatest. Okay, so back to stem and leaf plots. Our data set is ordered, so let's see what this data is about. Last year, Mrs. Vore asked each of her AP Stat students how many pairs of shoes they owned. The results are shown below. Use this data to make a stem plot. So this is 68 observations, or I asked 68 students. Typically, you would count that up on your own, but just to save you a little bit of time, I'm letting you know how many you should have because you know that I like to go through and verify that I included all of my observations. So then the next thing we do is we look at the range of our values. So we're going from 2 up to 45. So that means that we need a stem at 0, Then we need a stem for 1, 2, 3, 4. So what these stems represent are the data values between 0 and 9. This one is the data values between 10 and 19, 20 and 29, 30 to 39, 40 to 49. We draw a line separating our stems from our leaves. Then we start laying down our data points. So in order to graph a 2, you put it on the 0 stem. And you read that as 0, 2. And 0, 2 is just 2. Then you have a 3 and a 3. So I would either cross them out or cover them up with your finger. I want to leave adequate space between each number because when you go to finish this plot, you are going to need to stack the numbers vertically, just like in a dot plot. So we want to make sure that we leave enough room. Okay, then we have 3 4s. We have 4 5s. We have 4 6s. We have 3 7s. We have 5 8s. And 4 9s. So that is the first part of our stem and leaf plot. So what this number means is 0, 2, 0, 3, 0, 3, 0, 4. So those are all of our data values between 0 and 9. Now starting at 10, we move down to this line. So in order to write 10 in a stem and leaf plot, the 1 is here, you write the 0 here. So this represents 10. And then I write another 0 for 10. 0, 0. So we had 4 10s. Notice that I'm lining those data values up vertically as best as I can. Okay, next up I'm going to write 11, so that means I just write a 1. So now this is 1, 1, that's 11. Then a 2, 2, 2, 2. So I had 4 12s. Now we have 4 13s, so I'm going to go 3, 3, 3, 3. I'm just double checking that I'm including all of them. So now, just to verify you're at the same point as me, you have one more 6 up top and we stopped the 3s. So what goes underneath the last 6 is the 4 for 14. And then 15 goes under the first 7. We have 3 16s, so we're going 6, 2 17s, 3 18s, and 2 19s. So we have one extra 9. So just to make sure that we're clear, these are all of the data values between 0 and 9. These are all of the data values between 10 and 19. And remember, this means 10. This means 12. This means 13. Okay, now we're on to the 20s. We have 1 20, We're still lining up these digits vertically. We have a 21, we have a 24, two 25s, a 26, and three 27s. So your last two should line up with your last 7. These are the data values between 20 and 29. Okay, next up is 30. We have a 30, we have a 31, 35, 37, 38. This is 30 through 39. And then lastly, we would have 40 through 49. So we have 140, 143, 145. So I would argue that this was much faster than, or is much faster than a dot plot. I like that you can see all the data values, and I also like that you can see the shape of this data. So if you're looking at this data, what I really need to do is rotate this. And we can see that we have a lot of values over here on the left, and then it drops off dramatically over here on the right. So I can see a much more interesting shape to this data than I did with the dot plot. I'm pretty sure that when we went through histograms, I explained to you that this data set is what we would call right skewed. So let's make sure that we did all the things that we needed to do. I need to label my graph because it is a graph, so I need to give it a name. This is number of shoes owned and then up here in my instructions, I order them, I decide on the stems, I write all the leaves, and then I need to add in a key. This is the thing that people miss most often when making a stem and leaf plot. This is the thing that people miss the most when making a stem and leaf plot. Stem and leaf plots are easy to make. What ends up getting people is they lose points. They only get partial credit because they don't make the key. So here's what the key looks like. We need to show to an outsider looking at this graph, we need to show what this means. So we're going to say to line 4 means 24 pairs of shoes. So that's our key. There are many different kinds of stem and leaf plots that you can make. There are stem and leaf plots where the stem is 2 digits instead of 1 digit. So we always want to make sure that we write the key or how we're supposed to read the stem plot when we make it. And just for my own reference, you don't have to do this when you make a stem and leaf. I just want to make it clear to us though. The left-hand side is the stems. The right-hand side are the leaves. So there's one other thing that I want to discuss when it comes to stem plots. In fact, maybe I want to wait on that for just a second. So now that you've made a stem plot for the shoe data, let's go back to the berry bonds data and let's make a stem and leaf for the berry bonds data. So I can do the same title In fact, maybe I'll just use this as my title. I'm just going to make my stem and leaf right underneath this. Okay, so our minimum value is 16, our maximum value is 7. So I'm going to draw a line. I'm going to include 0 even though I don't have any values at that. If the data would have gone from 35 to 65, I would have just started at 3. But because our first one is in the tens, it's fine to just use a 0. Okay, I want you to see if you can decide what your stems are. Don't pause. I'm just going to stay on the video with you, and you see if you can decide what the stems are. If you feel confident, write them down. I'm still here. You're just supposed to be writing your stems. Okay, I'm about to unpause and show you my stems. Okay, you need 0 to 7. 0 to 7. Now, because your numbers need to be ordered from least to greatest, you don't want to come up here and use this data because this data is not in order. You would never put 2, 5 and then 2, 4. This is not allowed. It needs to go least to greatest. So use the dot plot, and I want you to complete the stem and leaf for these 21 data points or observations. So you don't have to pause because I'm going to freeze my screen and just do it while you do it. I should play some music for us so that we can live our best lives. I'm still here. I'm just making my dot plot. Hopefully you're doing the same. Or you're probably mooey bored. You're probably thinking right now, Miss 4, get a grip. We're trying to do our work. Stop talking to us. I already messed up. I'm still here. Hopefully you're still working on yours. Are you guys still doing yours? Still doing mine. Feel like it's taking me forever. Okay, I think I'm almost done. I think I'm done, so what I'm going to do now is count up my leaves and make sure I have 21. Oh dang, I do. Okay, if you're not done, pause me because I'm about to unfreeze and show you. So here is my stem and leaf plot. I think that was way quicker than the dot plot. And interestingly enough, I think that this shows the shape of this data a lot better than the dot plot does. So if you ignore what we think is an outlier, I still think that this guy is really unusual and an outlier. This guy looks left skewed. Remember that little skier that I told you about? Hopefully I told you about him. He is skiing down to the left-hand side. So without that outlier over here, I would say that Barry Bond's data is left skewed. The skier is skiing to the left. Anytime you have a stem plot, you do need to turn your stem plot like I have it so that you can see the shape of the data. So if I turn it back right side, I'm going to note here that I think that this looks left skewed, especially without that outlier. Okay, there's one other thing that we need to do. We titled it. Well, actually, we stole the label for the dot plot. That's fine. Can you remember what we should be doing? I'm going to draw a hat on my skier while you figure it out. I'm going to make my skier have longer hair. Okay, hopefully you're thinking that we need to make a key. So on this one, I could say for line 0 equals 40 home runs. If you don't make a key, you will lose credit. So now on this page, we have our dot plot, we have our stem and leaf plot. The dot plot doesn't really do a great job of showing shape because on a dot plot, you have to put every single tick mark. The stem plot, though, does give you a good picture of the shape, and I would say that shape is left skewed. Both of them show you very clearly that there's this unusual point here that is probably an outlier. But overall, between the two, I think that I probably like the stem plot better than the dot plot. Okay. Back to our stem plot page, there's one more thing that we got to do. So for the Barry Bonds data, that was a good data set to use because we only had 21 observations. But this guy has 68 observations that we are trying to record on 5 stems. If we want to get a better picture of the data, what we're going to want to do is split the stems. So what we're about to do is called splitting the stems. So instead of just having 1 0, I'm going to have 2 zeros. So I'm going to go 0, 0. And 1, 1. 2, 2. 3, 3. 4, 4. So it's like we're literally splitting the stems in half. The first stem is called the lower stem. The second stem is called the upper stem. So what this means is that on the lower stem, we are going to write observations that are between 0 and 4. And on the upper stem, we are writing observations between 5 and 9. So I'm going to move those down now. I'm going to go 2, 3, 3, 4, 4, 4. Now I drop down to the upper stem. That's going to be 5 through 9. So I'm going to have 5, 5, 5, 5, 6, 6, 6, 6, 3 sevens, 5 eights, and 4 nines. So upper stem is 5 through 9, lower stem is 0 through 4. Okay, it's similar now on the 1. On the lower stem, you're doing 10 through 14. And on the upper stem, you're doing 15 through 19. And you don't write these little things that I'm writing here. I am just writing this for your reference so you know you can remember how do you split the stems. So 10 through 14. Okay, so on the lower stem, we're putting 0, 0, 0, 0, 1, 4 2s, 4 3s, 1 4, and that's it. On the upper stem, I'm putting 1 5, 3 6s, 2 7s, 3 8s, 2 9s. So you now see if you can determine what you should do to finish out this plot. So remember, this one was 0 through 4. This one 5 through 9. This one is 10 through 14. This one is 15 through 19. So hopefully you're recognizing that the first two, the lower two, is going to be 20 through 24, and the upper two is going to be 25 through 29. So I'm going to freeze my screen and finish this at the same time as you, so you don't have to pause me. And let's see if you can finish splitting these stems. I'm still here. Okay, I'm about to unpause, so if you're not done, I want you to pause and come back when you're ready. So this is what your split stems should look like. If I zoom out now and I compare the two, it's the same data set, but I feel like you can see the shape of the data a lot better if you split the stems. It is very clearly right skewed. This one, I don't feel like it's as easy to determine that it's right skewed because you have these two really long stems and then you have these shorter ones. But if you split those stems, you can see the more gradual decrease that you see when you have a skew. So you start up really high and then you drop down. So I think that we would determine that this shape of this data is left skewed. We want to look at center. We're going to skip that. We look at spread. I don't feel like the spread on this data set is too large. I feel like this is a pretty good data set. All of the data values seem to be clustered between 0 and about 20, 29. So I think that the spread is okay on this. shape is right skewed, and I don't think that there's any unusual values. I think anything past 30 is obviously kind of unusual because most of the data is 0 to 29. Lots of data points over here, few data points over here, but I would not say any of these are outliers. I do not think any of these are outliers. Okay, so I just want to highlight that this key applies to both graphs. And then I want to make sure that I distinguish or make note of the fact that splitting stems or split stems to see the shape of the data better. So use split stems if you have a very large data set and you want to see the shape of the data better. So on the original one, you can see that it is right skew, or you get some kind of indication that it is. But once we split the stems, I think that you can definitely see the right skew. Okay, I think that that's it for stem plots. We did the ones on the shoes. I asked you to go back and do the ones for berry bonds. So hopefully you're feeling pretty good about dot plot and stem and leaf. If you're feeling a little iffy on histograms, that's totally understandable. Yeah, so make sure that you do your can you do for histograms. There's two problems there. I will probably have you make the stem and leaf for those data sets when I see you in class next, just to make sure that you feel good about making a stem and leaf plot. So as usual, if you have any questions before you see me next, just email me. Otherwise, love you lots. Good job making it through all these, and make sure that you get your Can You Do done.